Guys, and welcome to this tutorial. This tutorial comes from the RPDP tip site, and just in case you didn't know, I do this all on my own. I just use their questions because it's easy. That's really it. And hey, today's question, we're going to know about the strength of gravitational forces between two objects increases with mass and decreases with distance. Sounds a lot like electrical force, doesn't it? If you haven't heard that one yet, you might want to go watch that video. Oh, just a little plug for me. Okay, of the four fundamental forces, which is the least powerful? Well, guess what? Gravitational force. Nuclear force, no matter what, should be clued out. You might be struck between electromagnetic force and gravitational force, but of the four fundamental forces, gravitational force is the least powerful. And remember to turn on the pin. There we go. What is the cause of gravitational force between the Earth and the Sun? Well, A, the Earth's magnetic field causes the gravitational force. B, the Sun's rotation around about its axis causes the gravitational force. Nope. None of these are right so far. But the masses of both the Earth and the Sun cause the gravitational force. That's it. The gravitational force is about mass, guys. Okay? So, remember, mass is a key component of gravitational force. Gravitational potential energy stored within the mass is a direct result of A, the volume of the mass. Nope, that's not it. Okay? B, height of the mass. This is the correct one, and for a minute it actually threw me because then I needed to remember that height is also like distance. Okay? So it's the distance. There you go. Rotation, nope, surface area. Okay? If the height of an object held above the Earth's surface were doubled, the gravitational potential energy associated with the object would be, if the height were doubled, it would be twice as great, guys. Okay? So if I double the height, then I'm going to have double the gravitational energy. What diagram represents a system with the smallest gravitational potential energy? Okay? So, gravitational force. The bigger the distance, the smaller force. Okay? So, we're looking for the smallest gravitational force. So, by knowing that we need to look at distance, we're going to eliminate diagrams 1 and 2 because they're closer together than diagrams 3 or 4. Next, we're going to look at mass because if the higher the mass, the higher the force. And when I look at diagram 3 and I compare it with diagram 4, 3 has the bigger mass, which means it would have a bigger gravitational force than 4. So diagram 4 has the smallest gravitational force. Two objects are at fixed distance between each other. As the masses of these objects increase, the strength of the gravitational force between them, well, what did we say about mass? If the mass was getting bigger, the force, what? Oh, it increases. Guys, it's not fluctuating. It's either going to increase or decrease. If I decrease the mass, the gravitational force is going to decrease. If I increase the mass, the gravitational force is going to, yep, you guessed it. You guessed it. You guessed it if you said increase. There you go. As the separation between two masses increases, the strength of the gravitational forces between them. So we're increasing the distance, guys. They maybe start this far apart, and now they're just getting further apart. And what did I say happened with distance? As the strength is going to decrease as distance increases. Okay? Strength decreases as distance increases. There we go. Next question. If the Earth suddenly became twice its current mass, but stayed its current size, what is the one effect which you would notice? Okay. First thing you need to know is mass is independent of gravity. And so we know that mass, if the Earth's mass doubled, it would have an impact on our gravity. So mass is independent of gravity. So any answer with mass in it is wrong. Okay? So your weight's going to change. And if the Earth suddenly became twice its current mass, but stayed its current size, your weight would be twice as great. So if you weighed 90 pounds and the Earth became doubled its mass, you would now weigh 180 pounds. You climb a vertically placed ladder that is 500 meters long. Which of the following would be true? A, as you climb the ladder, your weight would increase slightly. B, as you climb the ladder, your mass would increase. Again, guys, I said mass is independent. It has no effect based off gravity. So mass would not be the correct answer. As you climb the ladder, your weight would decrease slightly. As you climb the ladder, your mass would decrease slightly. So now we have to decide if it's our weight, because our weight is dependent on gravity, is going to increase and decrease. Well, as we get further away from the ground here on Earth, our weight would decrease. So as I climb the ladder, 500 meters is huge, guys. That's not a little distance. Our weight would decrease slightly. And we're talking a pound. Nothing worth climbing a 500 meter ladder for. Maybe you should eat a little less McDonald's today. Oh, shouldn't talk about myself that way. Okay. Your weight on Earth is a direct result. Well, what do we keep talking about? Mass, right? And gravity. So your weight on Earth is a direct result of the Earth's gravitational force acting on your mass. Okay? The mass of an object is directly related. It has nothing to do with gravity, guys. The amount of space, that's volume. Okay? So the amount of material. Mass is all about the amount of material that's present. That's what mass is. Okay? The location of the object in space, that would be more about, would have nothing to do with mass. The space shuttle is orbiting Earth. The astronauts inside the space shuttle are in a gravity-free environment. C, will experience an absence of mass, are in constant free fall and appear weightless. D, will experience an increase in weight. Well, if you've ever seen pictures of astronauts, what are they? They're floating around and they kind of appear weightless. In order to stay put, they kind of have to strap themselves in. And that's what's going on. As the space shuttle orbits the Earth, the astronauts inside the space shuttle are in constant free fall and appear weightless. Which of the following statements best explains why an astronaut weighs less on the moon than they would on Earth? Okay, guys, think about the moon. Does the moon have less mass or more mass than the Earth? I hope you're all jumping up and down and saying, less. Oh, wait a minute. If it has less mass, it has less gravity force. Oh, that's why it would weigh less, because there's less gravity on the moon. Okay? So, correct answer. As the astronauts travel away from the Earth, they lose mass. No, I should say lose, not lost. I don't know. Okay. They lose mass, I guess. On the moon, there's no air, and this lack of air pressure... No, that's nothing but what we're saying. The moon has less mass, so gravitational force... There we go, guys. That's what I was telling you about. Okay? That's the correct answer. Because it has less mass, gravitational force is less on the moon's surface. Which of the following situations would cause your weight on Earth to increase? Weight, right? Weight. We're not talking about mass. We're talking about weight. The distance between the Earth's core and you doubles? Nope. Your mass is doubled and your distance to the Earth's core is tripled? Nope. Your mass is doubled. Okay, that makes sense because that would cause a weight increase. Oh, yeah. And the Earth's mass remains the same. That would cause a weight increase. Okay, everything else was also impacting Earth, which also would not necessarily impact your weight. But if we double our mass and the Earth's mass remains the same, we're going to have an increase in weight. Okay, guys, I hope you found this tutorial helpful. Get busy, get studying, get done what you need to do.